Okay, so welcome, and here I'm going to do some examples of solving conjunction type inequalities, compound inequalities that are conjunctions, okay? So these are conjunctions because this is solving for x that is going to be between these two values. So again, it's less than 12 and greater than 5 in this case. So we're going to solve this for x though, okay? So I'm going to do the first one the way they show you in the book, the way I showed you in the last video, those 3 steps, okay? So the first thing I'm going to do is, because the way the compound is a conjunction, which means an and statement, or an intersection, right? So I'm going to write this as two simple inequalities connected with and. So this is going to be 5 is less than x plus 3, and x plus 3 is less than 12. Okay? So now, I'm going to solve each of these separately. So that means I'm going to subtract 3 from both sides, and I get what? I get 2 is less than x, and over here, I'm going to subtract 3 from both sides, and I get x is less than what? 9. So now I'm into step 3. And step 3 says, okay, now let's put these together and find the solution set that's the intersection of these two solution sets. So I want everything that is greater than 2 and less than 9. Well, what does that mean? Well, let's write it this way. That means what? That means x is less than 9 and greater than 2, right? Or if we put it in interval notation, that means I want all values of x that are from 2 to 9, right? And I use parentheses because there's no equals, okay? Or if I graph it, right? So if I graph it on the number line, I want what? So so I'm going to put a parenthesis here and a parenthesis here. Let me use a different color. So I'm going to do parenthesis here, and shade that in. So just show you graphically how you graph that. Okay? Now, let's do it a different way, very similar way. Right? But watch what I do without the and. So let's do the next one here. And what I'm going to do is, instead of splitting it up into and, I'm just going to leave it as a compound inequality. Watch what I do. So what I'm going to do is, whatever I do to the middle, because I have to isolate the x, right? I got to get the x by itself here, right? Okay, so in order to do that, I've got to add 7 here. Well, if I add 7 here, I'm going to add 7 to the other 2 places as well. So if I add 7 here, then I've got to add 7 here, and I've got to add 7 here. Okay, to keep the relationship, the inequality the same. Okay, so now what I'm going to do is, this is going to go to 0. Less than or equal to x, because these go away, and then 7 plus 1 is 8, so this becomes 8. So now I've solved it. So now, see how I did that? So I end up the same place, right? I end up with a compound inequality. And so again, now in interval notation, this would be the same as, now I'm going to use brackets because it's an equals, right? There's an equal sign involved. So it's going to be a bracket. So it's going to be 0, comma 8 with a bracket. Or if I do graphically, right? So if I do it graphically, so then here, I would just do a bracket here at 0 and a bracket here at 8 and shade in the middle. Okay? Let's do the next one. So here, again, I want to isolate the x by itself, right? That's the whole purpose. If it's a conjunction like this, right, then I can go ahead and leave it this way. Now, if you want to split it up into two simple inequalities with an and solve them separately, that's fine. You go for it. Again, you'll get the same answer. Okay? Here, if I want to get the x by itself, what do I have to do here? Well, I'm multiplying by 3, so I have to divide by 3. So that I get a 1 there. So I get a 1x, or just x. So if I divide this by 3, then I have to divide this by 3, and I have to divide this by 3. Okay? Which means, what happens here? Negative 6 divided by 3 becomes negative 2, less than x, which is less than negative 1. And so what's the result? The result is I get 2, comma, negative 1 as in interval notation, right? So I can use the inequalities, right? I can use this, right? I can use set builder notation. I can say the set of all x such that, what? X is greater than negative 2 and less than negative 1. Okay? That's it. So let's do the last one. Okay, so let's do this one. Now we've got a couple things going on here, right? But again, you just solve it the same way. Whatever you do to the middle, you got to make sure you do both sides. So I'm going to subtract 1, or excuse me, I'm going to subtract 7, right? Because I'm getting rid of the 7, so I'm going to subtract 7 from both sides. So that gives me 10 is less than or equal to 5x, which is less than or equal to what? 25. And now I'm going to divide the middle by 5, which means I'm going to have to divide everything by 5. And so this gives me 2 is less than or equal to x, which is less than or equal to 5. And so what happens? My solution set is going to go from 2 to 5 with brackets, because I can include the endpoints. Or again, if I do set builder notation, I can do the set of all x such that x is between is greater than or equal to 2 or less than or equal to 5. Okay, same thing. Okay, and then of course I can also show it graphically, again, just in case if I do ask you to show it graphically, make sure you know how to do that. Okay, practice this. But other than that, have a great day and I'll see you next time.